I'm going to talk about some special types of solutions or weird types of answers that you might get when solving and graphing compound inequalities in this video. And I just want to preface by saying that not all teachers go into these examples. These are examples maybe you'd see in an honors class, or depending on your teacher, you might see it in Algebra 2. But this is not something that I've seen a lot of practice questions on the Keystone test. So we're going to go ahead and look at these. These are how you truly kind of really make sure you have your inequalities correct. So anyway, here we go. So there's going to be some different types of solutions. We said typically in problems that AND problems will look like this. You know, you'll shade in between the two numbers. And we said with OR problems, typically we shade outwards. So, you know, you'd have your number line and, you know, depending on what your circles are, if they're open or closed, it'll look something like that. Okay, so there are possibilities other than these two. Let's look at number 12, and we're going to go ahead and try to solve something like this. So I'll solve the left side just like before. I'm going to subtract 2 from both sides. So I have x is greater than 2, and I've got x minus 5 is greater than 2 on the other side. So I'm going to add 5 on both sides. That will give me x is greater than 7. Okay, and now we're going to go ahead and try to graph this. So I've got my x is greater than 2 line, and I'm going to graph it. And you might assume, so people who aren't paying attention are going to do this when they're graphing this. They'll say, oh, 2 and 7, you got to shade in between these because it's a line like that. So not always. Here's an example of when you will not shade between on an AND problem. So if we graph an open circle, this will be going towards the right, greater than 2. We need all the greater or bigger numbers. We'll do this one in blue here. So x is greater than 7. I'm going to go out to 7. And you notice here that both of these lines are going the same direction. They're not going towards each other like previous AND problems. Another thing to think about, let's go back to the previous kind of metaphor I used here before, that an AND problem we can think of like hail. And an OR problem we said we thought of like rain. Okay. We said with hail, since this is an AND problem, we need 2 roofs over our heads so that we don't get hit with this really heavy hail that breaks through one roof. So if it were hailing up here and we wanted to find out where our final solution is or where it would be safe to stand, obviously you wouldn't want to stand, you know, out here somewhere on this last number line because you're going to get hit in the head by hail. You don't have any roofs over your head. Now, over here with the red number line, again, this still isn't enough protection because this hail is so strong it's going to break through one roof and land on the ground over here somewhere, so you would get hit standing here. Where you will be safe is everywhere to the right of this 7. So that's where we have 2 roofs over our head to protect us. So our final answer on the number line should look something like this. You may also notice that we didn't even really use this red graph up here. The only graph that mattered was that x is greater than 7. Another way to think of this is saying, you know, you have to bring at least $2, or I should say more than $2 on the field trip, and you also have to bring more than $7 on the field trip. Well, you know, there's no point in really saying it has to be greater than 2 if it's also got to be greater than 7. So really the only part of the solution that we're going to keep in our final answer is x is greater than 7. Okay? The key there was, again, AND problems don't have to always go in. You can see that as we start to study this a little bit more, that it really comes down to where they overlap. They both overlap from here over. Okay? So we'll go to the next one. All right, this is an example of an OR problem, so we'll do this the same way. So I'm going to just start by solving away. So I've got -3. I'll divide on both sides. You'll get x is less than or equal to 3. Or, now we'll go to the right-hand side, divide by 5 on both sides, and we get x is less than -2. Now, again, you might assume if you're graphing this, and since it's an OR problem, people want to assume that this, you know, if I were to graph this, just go right to the answer. I'd put a closed dot at 3. And again, notice I did flip the sign here. That's also important to note that since I divided by a negative, I flipped the sign. But if people are graphing this, they'll put a dot at 3, a dot at -2, and they say, oh, it's an OR problem. It's got to go out. Not necessarily. Here's an example. So watch. Watch closely. Okay, so x is less than or equal to negative 3, or excuse me, positive 3 would be shading here to the left. So I'd shade everything over here. Now, x is less than negative 2. That's also going to be shading to the left. Oh, and that should be that should be an open circle here. So let's change that around to an open circle, shading out this way. Now, you might notice here, again, we think of or, not like hail. Or is a little bit less dangerous, we should say. We think of or like rain. We're just looking for either one of these things is. So if it's raining up here, an easier way to think of that is, if it's raining up here, okay, up here, we want to think about where could we stand so that we wouldn't get wet. And rain doesn't go through roofs. Rain just rolls off of roofs unless you got a leaky roof. So we're going to look at where is it okay for a person to stand on this number line so they wouldn't get wet. And to look here, anywhere from the 3 all the way over is going to be a safe place to stand because we're not worried about 2 roofs over our head like an and problem. If it were an and problem, it would just be this blue section of the number line. But since it's an or problem, well, we can take both pieces of the bigger part of the number line because we don't necessarily need them to overlap. And this would be what your graph would look like for this problem. Okay, now going back to the final answer, notice that we used that x has to be less than or equal to 3, but we didn't really use the x is less than negative 2. It got swallowed up by our final answer here. So what I'm going to do again is I'm going to cross that out. It's not important. All you really need in the final solution is that x is less than or equal to 3. Okay, and we're going to jump to 2 more special types of solutions here. So these first 2 that I did, this and problem and this or problem, show you how you would graph this when the arrows are both pointing the same direction. Well, there's 1 or 2 more cases we haven't really talked about. Okay, here's the first one. Again, I'm going to solve this like normal. This is an and problem. And I'm going to start by subtracting 1 on both sides here. So I get x is greater than or equal to 3. And then I'll sneak the word and in here. And then we'll subtract 5 over on this one. So we'll get x is less than or equal to negative 4. Now, if you notice here, if we have x is greater than or equal to 3, again, you might just assume people not paying attention are just going to say, oh, it's an and problem. I'm going to shade in between. Look carefully here. All right, so and we said is like hail too. So these are the dangerous problems. Okay, so what we're going to do is we're going to take this graph at positive 3, and this is greater than, so we're going to shade to the right. And we've got x is less than or equal to negative 4, so we're going to shade to the left. And you might also think, well, hey, this is like an or problem. It's shading outwards, so people might be tempted to also put their final answer shading outwards, from these 2 lines and have their graph look something like this in their final answer. But remember, this is an and problem. You can't treat it like an or problem. So we need to find out where these 2 graphs overlap. Or again, another way of thinking about that is if it's hailing outside, very heavy hail, and it breaks through one roof, where is it safe to stand? And in this problem, no matter where you're standing on this number line, you'll never get an overlap or you'll never get 2 roofs over your head. So there's actually no place where this will actually be true. Or another way to think of this is, think of a number that is both greater than or equal to 3 and also less than or equal to negative 4. Well, how could a number ever be bigger than positive 3 or equal to it, but also be smaller than some negative number? So what we write in this example, when there's no place on this number line that this is true, we can put the circle with the slash for it, or with the slash through it, or all that means is no solution. There is no possible value of x that will ever make this statement true. So no matter what you plug in there for x, there's not going to be an x that exists that makes that statement true. Okay, so we got 1 more to go here. So that was an example, of an and problem that was going outwards. Okay, so that was an example of an and problem that went out. Again, you can see that the word and or, these are very important words here to these problems. Okay, so we got 1 more to go. This will be the last example I'll do. And this will be an or problem. So we'll start by solving. I'm going to add 1 on both sides. So we'll get 2x is greater than 6. And I'm going to divide by 2 on both sides. So I get x is greater than 3. Over to the right here, I'm going to add 17 on both sides. So I get 3x is less than or equal to 18. And I'm going to divide by 3 on both sides to get x is less than or equal to 6. And I'm going to sneak that word or in the middle. Again, very important. That word changes how we graph this problem or how we think about the solution. Now, going ahead and graphing, we'll graph the red one first. Greater than 3 will be open circle out to the right. And x is less than or equal to 6 will be a closed circle over to the left. And again, you can see that this is an or problem, but it's going inwards. If it were an and problem, we're used to these. You would just shade, this in-between section between the 3 and the 6. You would just shade between those two numbers here. But since this is an or problem, that's not going to work here. Again, with or, we're looking for where either one of the solutions or either one of the graphs are to graph it. Or again, another way to think about that, we said that or is kind of like rain. It's not as dangerous as hail. As long as you have one roof over your head, you're okay. So think about if it's raining up here. Say we got, a pretty rainy day. Where could you stand on this number line so that you wouldn't get wet? And you might actually notice here, the answer is, well, you could stand anywhere. No matter where you stand, you're always going to have at least one roof over your head. So we're going to graph this entire number line as our answer. So the whole number line is safe. This, again, is an example of what happens when an or problem goes inward. And to actually write our solution, again, this isn't really the best answer. We can go another step and say that any real number or all real numbers will make this statement up here on number 15 true. Okay, so that'll make any real number will make that statement true. Again, if you like to abbreviate that, you could also use the double-lined R for that, or reals, or in a previous video, I talked about reals with the Z. Don't do that for your math teacher. They won't know what you're talking about. But, if you want to be hip and have the reals with the Z, you can do that too. But again, that's why we always have to check. We can't just assume or problems and problems always go in or out. We have to make sure that we check as we're graphing to make sure that they either overlap at a certain spot or they, or you're graphing where each one is. And I think that the rain and the hail example that I came up with is a helpful way to think of that.